Hi and welcome to my session about crafting sport activity service using node.js together with OpenAI. Today we are diving to the journey through the sport activity suggestion service using OpenAI. All generation will be based on our indicators. Let's jump into the lineup and we'll see what's there. First of all, we're going to jump into the small introduction. We're going to talk a little bit about OpenAI. We're going to set up our Node.js application. We will check how to connect and how to do this connection, how to do prompting, messaging, what's the difference in the role. We will check the options, the body, how to look like this connection, and how we actually can get those suggestions from OpenAI. And then we will wrapping up everything together, and finally we do some conclusions, and we will discuss about the possibilities. So, as I said, we are going to build an application which will be able to send to us daily sports activities based on our indicators. So let's take a look on the schema and in order to better understand how it's going to work. So the service is designed to provide users activity based on the indicators and last activity. It's like a circle of the data. You accomplished activity. Next time asking for a new one, AI analyze it, your data, and server sends to client the results with new sport activity with plan how to do that. Okay, so there is a variation of sport activities. To refine the AI suggestions for users, we will compile an extensive list of variation of sport activities. This list will be provided to OpenAI API in message. The AI will leverage this information and will take from the list the activity what field based what feeds based on indicators and last activity. So literally you get the last activity, you have your indicators, and you get the suggestion based on that information. So as I said, we're going to use an OpenAI. By utilizing OpenAI technology, we can access powerful analytics tool that examine user input such as a lifestyle, height, weight to generate custom tailored activity plan specifically for the user. The benefit of using OpenAI in our case lies in the sophisticated algorithm which can be trained as we want. To start building our service, we should first define the scope of activities and use data point that are relevant to our application. So we going to use, as I said before, Node.js. We have to accomplish that connection. So that's what we plan to do, to employ Node.js in conjunction with Express.js. Which will serve as a web application framework to manage routing, controllers, modeling, and communication with database. We're going to use Knex.js. So before to jump into the code to check it out how we going to deal with all of this stuff, we have to set up our OpenAI account. For that, you have to go to openai.com, create your organization in order to obtain the API key. So there is going to be a API account where you can set up all of this stuff, and then finally you're gonna get your open API key, right? So in this case, so we're going to dive into the setup Node.js service itself, and for that we're going to in my case I'm just using the create Node.js application, and I'm going to use the framework Express. Will generate for me necessary files to build my Node.js service. So let's take a look on the schema, how exactly going to look like our application. Well, So our source of data going to be on Postgres. We're going to set the user, indicators, and activities. Activities is like a history of the list of activities of user. Also, indicators have to belongs to the user. In order to get this request to Postgres, we're going to use the nextjs. But in front of all of this, we're going to use the express.js, which is gonna, as I said before, handle our routing, responses, and to generation of data. We're going to use OpenAI. To handle session of the user, we're going to use Redis. We're not going to focus so much for that because this is not topic about this. We're going just a little bit touch that part. But first of all, before we generate the, in order to install everything, let's take a look what's the stack of dependency we're going to have in our package JSON. There is going to be, as I say, knex, Postgres, Redis, what we're going to use. In my case, I'm using the validator just to validate login user and sign up, but this is the cover of the authentication part, but which is very important. We are going to use the OpenAI package, node.js. You have to just install it and we can start using it, right? So you can see this over here. This is version 4 for now. And now we're gonna create, we have to create an .env file, and this is the stack of my variables. And as you can see here that I'm using OpenAI API key over here. So, and that OpenAI API key will be provided to the configuration of OpenAI package. Well, now how the structure of this application has to look like. We have a user which has, as I said, indicators and activities. Based on those indicators, which is weight, height, lifestyle, and last activities, what been accomplished. Last activity, it could be running on the distance and stuff like that. Based on this information, we have to provide this information to OpenAI. OpenAI will generate that information to us, and that's how we're gonna get a new sport activity for today. It's actually not specifically for today because route will allow us to generate the data. Depends when we want it. It depends of the client. Like I want this daily, or I can just get this by weeks or by month. But anyway, we're always going to look on the indicators and activities. But how we're going to do this? The whole flow on the request, right? So request for the sport activity will, of course, go through the authentication plus Redis. Redis will help to us with cache. Then we're gonna get user from where we can get the last activity. Together with indicators. Then we will build the based on this data information a prompt. That prompt will go to the request to OpenAI API, and then that's how we're gonna get the response with result of sport activity. Before to dive into this stuff, how we're going to generate our prompt, let's briefly take a look on the next setup, how I built it. So this is the connection to database with different environments. So that's how we can get our data from DB. And here by migrations files from Knex, we can see how structured our tables. In our case, we're going just to have very simple user, which going to have first name, last name with username and email. We just need this for sign up. So because that's a service application going to have that users, and that user going to have, each of them going to have indicators. It's just one row in the table for belongs to the user, where we're going to store our age, weight, height, lifestyle, and depends on, and based on this information we're gonna do those generations. So here also we're going to store, as I say, as a history of the activities of the user. Here you can see how what's the data we're going to use. That's going to be activity type. The activity type is actually list of activities. This is the constant of the list of activities, and duration, which is has to be duration of how long that activity has been accomplished, during that which time. So, and in order to start build our service, we going to use some base abstract model, which going to deal for us in order to request data from database. So this is the base model, and based on a base model, we're going to build our models for indicators, for user, and for activities. So user model extending the base model, and we have to assign the table name, which is users, and from against that table we're going to be able to create user, find by email or find by username. So that part we will simplify in order just to reuse those models across our controllers. So the same approach with indicator model, when we able to find all indicators by user ID or updating by user ID. So all of these methods is actually leveraging these indicators through this model, and we can deal like that with database. So activity model absolutely the same. We just have to find the activity by this using this method. So, and now slowly we can arrive to the initial point where our application is starting. So very easy one. We just gonna start our application. We identify the router, and we do this connection to Redis, and literally that's it. So let's briefly take a look on the Redis. It's just a plain setup. We have to create a client. We do this connection to the to Redis using our env variables, and I'm just reuse that, and I create the class for Redis in order just to simplify the communications request to Redis in order, for example, to set session or get session or delete session, right? And authenticate auth middleware actually looks also pretty straightforward. There is nothing specific ones, like we have a JOT tokens, and we have a secret, and that's how we deal with our auth middleware. So that means, like, when we using, for example, Postman, we have to provide the first of all we have to sign up, then we're gonna get the token, we have to use a bearer token, and then we can start using our endpoints in order to get our suggestions from AI. Here are the list of routes. So we can, as I said, we deal with our authentication router, and we're using the auth middleware, where we have all of this checks in order to provide to us the data about user. Of course, we can have an access to the session in order to get all of data regarding the user, and you can see in the end that we able to get the suggestions by the /suggestion, and by the slash indicator we have to be able to update our indicators depends on the user. Okay, so now let's try to understand what's the expectations we have from the application. Here we have a GET request to the API with a suggestion, and that suggestion will have to send to us a JSON, which we can, which with this JSON we have to be able to deal with on our other client-side application. Let's say, we can assume that this is going to be some React Native application, or even on iWatch, you can get this application and we can deal with this JSON, right? So in this case, as you can see, we have an activity type, which cycling. The duration have to be 45 minutes. This number in minutes, so we're expecting something like that. We have to have a description, how exactly it has to happen. Then we have to check the how much we have to consume water during this activity. And here you can see also in the explanation why we need to do this. Okay, so, and as you can see, the cycling is great activity, choose for you as a provides both and so on and so on. So it is explanation actually based on the last activity. So maybe explanation can be depends of, like, you did nothing previously, and this is going to be like explain like, hey, you did nothing the last time, and let's start from running, for example. And we have an array of plan, like how we have to start this exercise, how we have to deal with this exercise during the way, and how we have to finish that. So here is a bit different activity type. I just showing like this responses from Postman. This is another activity, skiing. In the same way, we have to deal with the skiing 16 minutes. Duration is after duration we deal with the subscription, how much water consumed has to be in milliliters, and explanation. Like you can see here, for example, based on your previous activity of CrossFit, that means that guy previously has a CrossFit and now he's dealing the skiing. Some of you may be thinking like, hey, what's the region or what's the weather that user having right now? Maybe it's a summer, but AI generating to your skiing. Of course, you can customize as you want your suggestion, depends of prompting, and this is the part is going to be next one. But let's dive into this communication between backend and the client, okay? And how it can works on the application itself with this timers. For example, as I said, we have a GET request with a suggestion, and bumps JSON just does response with this sport activity to the client. So timer actually invoke this API call, and then that's how we can get back this sport activity. And the same way in the indicator, hey, like I need just to update my indicator because my weight is changed, and the lifestyle actually a little bit changed. Depends of this activities what we accomplishing. And now we have to start configure our OpenAI in Node.js, and everything is super simple. We just have to provide the Open API key to the class OpenAI, and we able to reuse this OpenAI instance. And in the controller, as you can see, literally the all magic happens right over here. So get suggestion controller having this indicator, we asking from indicator model by the user ID, and we asking for the last activity by the user ID, and that's how by the indicator and last activity we got result. And result actually has to be set that we have to set that result also for the activity using activity model. We have to just insert what the activity has been accomplished. Of course, this is not ideal. I'm just showing the bare just the base model how we can deal with this. Of course, we have to insert the activity after real accomplished, and we can check it actually with a communication with a client, like to get some statistic from iWatch, and in such way only after that we can insert something to the activity. But now it's just like very simple, bare enough information how we have to deal with this, right? Because we are generating our activity based on the last activity, and we just sending this result for now. So pretty simple. So, and the most important thing, how we have to do this communication against openai API. First of all, we have to build our system prompt. There's two things what we have to understand, that there is a when we send a message to the completion, we dealing with the different roles. I will explain you a little bit later what's the difference between those roles, but previously we have to generate set up our prompts. Okay, so in my case, I provided the detailed explanation in my prompt for the system prompt, what exactly we are expecting from response from AI. What kind of response has to be, as you can see, that I'm telling that I'm expecting to get a JSON, and I'm listing all of those items in JSON, like how it has to look like, okay? And as you can see, that activity type is actually, this is the list of it's just an array of activities. I'm just sorting them and just provide here to this file, and this how we can set up system prompt and tell to AI how exactly what exactly we're expecting from AI as a response. And here you can see the last activity message, which means that if last activity exists at all, we have to provide this as a parameter, as a user prompt. User has his own indicators. Actually, activity also has a part of indicator, and that's how we're dealing with AI. We're telling like, hey, system has to return me a JSON with that kind of structure, based on indicators, based on something what we want to tell, like, hey, based on this indicators, please tell me what I have to do. And all of these parts we have to provide to the completions as a messages. And you can see here role system. We provide that content system prompt, which is that message where we are telling how we have to what we're expecting from AI, and a content for as a user prompt where we are providing our indicators. So let's a little bit take a look on the our setup of this completion. Okay, so what is this messages? Messages is the context of conversation with AI. Messages are like the back and forth text between you and the AI. So each message has a role to tell the AI who is speaking. Okay, so as I said, if the role is user, it's like the message is coming from a person using the AI, asking a question or making a statement. If the role is system, it's a special kind of message that gives the AI instructions or information about how to behave, but it's not part of the conversation itself, right? If the role is assistant, there can be another role is assistant. It's the AI own message or responses. Okay, so what you can see here, the temperature 0.9. Okay, so I will explain a bit that part as well. So is a temperature is a way of controlling how creative or surprising the AI responses are. If the temperature is low, the AI replies will be more predictable and safer. If the temperature is higher, the AI is more likely to give you unique and more unexpected responses. Okay, so and the model itself, the model actually is the version of the AI you are talking to, just like your phone has different models with a variation of features. AI has different models that can do different things, right? So some are smarter or more creative. That's so. And in my case, GPT 3.5 Turbo is a more cheaper and more stable model which we can use now. It's like I could say like it's more cheaper even, but anyway, we already can deal with this model and get a good result. Okay, and also I would like to mention another key, which is going. It could be as a configuration max tokens. It's not over here, but you can set up max tokens, which means the maximum numbers of pieces of text in the AI is allowed to generate in its response. Okay, so you can think of a token as a single word or punctuation mark. Okay, so max token sets a limit on how long the AI response can be. Well, suggestion controller has to be as I said, a little bit construct a little bit different. It's just a presentation of how we're gonna get this result. Each time when I get the result, I'm setting immediately from result activity type as the last one was there, but it doesn't mean that it's accomplished. It's really accomplished. Of course, it has to be in a different way, but in terms of presentation, it's in such way. And indicators have to be updated from result from the client actually. So we have to update to say like, hey, I'm doing like a bit different. My lifestyle is changed, and I have to update this my indicators. I have, I think, different weight, and those indicators will affect for the next activity what you're going to accomplish next time. So we sends from client the indicators, updating indicators, then they getting the activity, and then based on this information we get back the sport activity. And for update indicator, we have another controller where we have to just as usual deal with the indicator model. We have to update by user ID and set those indicators updates right away. And from database perspective, I'm using Postgres. You can see the list of activities. Here you can see the activity type has been accomplished with the specific duration. There is a user ID, and there is a history of the when it's been accomplished. Now it's like finally this. The session was long about the open AI integration, how we can deal with these prompt messages and so on, you can find this project and to check and play around by yourself from my personal GitHub account. You can just get the pull up a AI server and run it by yourself and play around. And of course, previously you have to set up your OpenAI account and get the API key. So thank you so much for the attention, and see you.